Welcome back. In this video we're going to see how we can use RCcontroller to do SocketIO communication. So we first need to let's first set up the SocketIO server. I have the server here, that is index.js, and this is the JavaScript code that creates the server. We need to use npm to install Express, SocketIO and SocketIO auth, and this block is what handles the authentication. We basically make sure the user is Joachim, and you have the password hello world. Now in the callback function for the onConnection event, when a user is connected, we log to the console to indicate the user is connected, and on disconnect we indicate that too. When we get a message, we log the message to the console, and because RCcontroller has to at least get something from our remote server, we send three values, 29, 383, and 35 to it as parameters. And because they are parameters, we need to have the prefix of capital P and the suffix of the new line character. So we send this message every 200 milliseconds, and the very last part is this block that handles the server creation. It just creates a server that listens on port 2000. Alright. To remind you, you have to log into your router's admin page and do basic port forwarding. Alright, you go to forwarding. First you need to bind a static local IP address to you need to bind it to a certain MAC address, which is the Linux computer running your server, your SocketIO server. I have the TP-Link router, and that's the model. Yours might be different, but I'm just using this to demonstrate how to do port forwarding and also do the address reservation for the device. So I have the local IP this bound to that MAC address, and that means whenever I connect to my router with this machine, its local IP would always be this. Now that will help us to make sure when we do port forwarding, we know that we know the machine we are sending the traffic to, or the machine that we are basically forwarding the traffic to. So the service port is 2000, the internal port is 2000, and that is the IP address, the local IP address. Now you need to also check out your public IP address, because you're going to use that for the SocketIO communication, since you want to access the server from the internet. So we come back to RCcontroller, we started and we create a new controller. I already did, and let's see what we have there. We have the connection URL, HTTP, the IP colon the port. Of course, my public IP isn't all zeros. I don't want to show the real thing here. I don't want to get hacked. And the port number you saw here, we are listening on port 2000, so our port number is 2000. We enter our username and password, and the write delay for our frequent control values is 200 milliseconds, which means after every 200 milliseconds we send our frequent control values to our server, the SocketIO server. Alright, and the parameters we add, so we need to add some frequent controls, and we need to add 3 parameters because we are sending in 3 values. In the real world, maybe 29 could be like a temperature reading, 383 could be light intensity value coming from a photoresistor, and 35 could be another thing, maybe another sensor, and this could be like variables containing the values, and they could be changing. The values could be read from the GPIO pins of some microcontroller. Yeah, so I already created my controller called my IoT. I have 3 frequent controls, which are basically switches. The first one, red, is a switch. We assume it controls a red LED. The yellow is also a switch, and green is also another switch. My SIG bar is, of course, a SIG bar. You can see the preview here, and it has a width of 200 with a minimum value of 0 and a max of 100. Alright, and then it has the 3 parameters. We are sending in 3, so we need 3 parameters. Sorry, here, yeah, 3 values. So say that the first one is the temperature reading. The unit is degrees Celsius. Param 2 has units, and my parameter 3 has units. Alright, so we have our details. We go back and then we have all our controls here. So let's connect to the server. We need to start it with Node.js. We navigate to the folder that contains the server, and we execute that for Node.js to start the server. Alright, so it says it's listening on port 2000. Alright, so I'm gonna click the connect button, and as soon as I connect, we're getting data. So every 200 milliseconds we're getting something from RCcontroller, and because they're frequent control values, we have the prefix of F, and the first 3 LEDs, the first 3 switches, which could be controlling LEDs in the real world, maybe lighting systems, let's toggle the values. I'm going to toggle the second one. Alright, so you can see it just changed to 1. The first one, that changes too, and then we turn them off. We can vary the sig bar. You can see that also changes. Okay, so the sig bar could be controlling like a door, maybe like a servo, anything you can think of that would need a range of values. Alright, so when we disconnect, alright, user disconnected. You can see it's off. Let's connect back, and you can see it's connected. Now our parameters are here. The temperature 29, param 2 is 3, and my parameter 3 is 35. These are the values we are sending from here. That is the parameter payload. So this device is the BeagleBone Black. It can run Linux, and I've actually run the server, the SocketIO server we just went through on this before, and it has GPIO pins that we can use a JavaScript library called BoneScript. Not just BoneScript, but there is also Cylon.js for IoT and robotics. They are all JavaScript libraries that can access these GPIO pins. So why do we need a device like this? We might need the GPIO pins to control stuff, because we can't just be getting the values. We can't just be getting the values from RCcontroller for nothing. All these values could be parsed and used to turn on or off the GPIO pins, and also like to control the PWM pins, and that could basically make your house a smart home. So you could also use a Raspberry Pi, an Intel Galileo or Edison for that too. Alright, thanks for watching. See you next time.